Hi, and welcome to Ironside's Take 30 with a data scientist. My name is Debbie Bond, and I am the manager of our partner ecosystem. And although Dr. Pam was not able to make it today because she had a client commitment, we have Jake Schneider, so we do have our Take 30 with a data scientist. Jake is here from DataRobot, and we're really excited to hear about MLOps and how you can get your models out of training and into the workforce. So as we go through today's 30 minutes, we're going to give you a little background on Ironside and our Take 30. Hand it over to Jake, who's going to talk about DataRobot and what MLOps could mean to you. And then, as always, we'll end with Q&A. Ironside is all about business outcomes. The tool is a means to the end, and we help our clients use data to make better decisions about their business. We have a holistic view of the whole data and analytics world, and data science actually fits into all of this. And today we're going to be talking about build, deploy, and govern. So a little bit about our Take 30s. We take 30 on Tuesday with a data scientist, Wednesday with a data advisor, and Thursday with a BI expert. Here are the sessions, some of the sessions that are coming up. We're really excited to have each of you join us. We try to also sometimes integrate them. So next week's Tuesday session, we're going to be talking about data science and with specific examples on higher ed. And that's also going to follow into Wednesday with some higher ed from a data and data governance, data catalog perspective. I also want to take note that if you go to the Ironside Group website, which is where you'll find this agenda and you can register, that on the very top right before the Take 30, we do have links so that you can schedule one-on-one time with Dr. Pam or our data advisor or our BI experts if you just have a specific question that you want to take one step further. I also want to share that we're now in block 2, a 6-week block of Take 30s, but our block 1 is now available from recordings. So these 6 recordings that we started out when we started our Take 30s are available again on our website if you go to the Take 30 page. And as I mentioned, we partner with the smartest technologies. We have a very robust partner ecosystem, and we're really excited to hand this over to Jake.
Thank you. So my name is Jake Schneider. I'm a customer-facing data scientist at DataRobot, and today we're going to be talking about DataRobot MLOps. So for those of you who are not familiar with DataRobot, we are an end-to-end automated machine learning platform. So we handle everything from data cataloging and preparation all the way through to productionalization and value management of your use cases. But today we'll be focusing in on the machine learning operations side of DataRobot. And so first, let me explain what is machine learning operations. One thing to note with machine learning operations is that successful AI adoption is still difficult and still being figured out. So based on market surveys, 96% of organizations experience challenges with model development. Of those who are able to build a successful model, 90% of them cite obstacles to moving these AI models into production. And finally, those who do that, only 1% of them are successfully able to monitor their AI and machine learning assets once they are in production. And a significant cause of this is what we call the production gap. With the machine learning pipeline, you probably have multiple different data science teams or data analyst teams who are using a variety of different tools and programming languages to build their own AI models. And this could cut across departments, it could cut across technologies. Every data scientist has their preferred method of building their own models. And at the same time, your IT teams need to deploy these models in different environments. So whether that's in the cloud, on-premise, through Kubernetes or Docker, each production system has their own unique needs for serving these model predictions. And this is where we have the production gap, where the tools and languages that your data scientists and data analysts are using are not the same tools that your IT team is using. And it can be very difficult to bridge the gap between the two to make sure that your models and your AI systems perform as expected and as needed. And so to solve this, we need tools that can help bridge this gap, where you can unify your model deployment, monitoring, management, and governance of all of your production AI systems so that all stakeholders can be able to use them in the way that they need to. So let me take a moment to talk through the fundamentals of AI adoption. And there's really 4 key components to making machine learning successful at your organizations. The first is production model deployment. So after you've built your machine learning model, you need a way to be able to deploy these models so that you can start to make predictions on new data. And the variety of different tools and languages make it difficult for your data science and IT teams to collaborate. The next aspect is model monitoring. Machine learning has its own needs for monitoring that goes beyond the typical IT system, DevOps kind of view. Machine learning is its own beast, and so we need to make sure that we're monitoring the health of your machine learning models, not just from the IT perspective, but also from the data science perspective. And third is the lifecycle management. So your AI models are not good indefinitely. There will come a time when their performance or their purpose is changing or degrading, and so at a certain point they will become stale. And therefore, you need a way to seamlessly and without interruption be able to update your machine learning models after they're in production. And finally, governance. Across all of these, we need the right governance in place to minimize risk and to make sure that your machine learning models are complying with your industry's regulations or your company's IT policies. And so this is what spawned the machine learning operations. So to finally give you a definition, machine learning operations is the technology and practices that provide a scalable and governed means to rapidly deploy and manage your machine learning applications in production environments. And as the visual here shows, its purpose is designed to sit at the intersection of your data science and IT operations teams. And so this is where DataRobot's machine learning operations product comes in. We provide you with one product for any deployment scenario. So whether or not you're deploying a DataRobot model, a custom model that your data scientists have hand-coded themselves, or even a model that is deployed entirely outside of DataRobot's ecosystem, you can use, but still monitored within one location. And so the monitoring we provide is agnostic as to where it's deployed or with what tools. Through the use of our monitoring agents, we can monitor any model in nearly any system. We also provide model lifecycle management so that we can help you identify when and why your models need replacing, as well as the ability to replace them without interrupting your service so that you can continue with your production systems. And finally, the enterprise model governance as well, where we provide a centralized governance system for all of your production machine learning models. So let me spend some time drilling into this a little bit. So first up, the one product for any deployment scenario. With DataRobot, we allow you to deploy DataRobot models on our own prediction servers so that you can start to consume the predictions in wherever you need them to be. We also give you the ability to deploy DataRobot models on your own servers, whether it's another cloud provider or on-premise. As I mentioned earlier, we can also deploy custom models on our own prediction servers. So this may be a sklearn model, maybe it's a Keras model. We have the ability to bring in your own custom models and deploy them on our prediction servers, as well as your own infrastructure, again, on your own cloud providers or your own on-premise infrastructure. We also have the ability to migrate these models across cloud and on-premise systems. So whether you want to build it in one deployment, maybe on our cloud, but then deploy it on-premise behind your firewall, we have the ability to migrate our models across multiple different clouds of environments, which can help with your own internal IT policies, as well as simply helping avoid vendor lock-in, where it doesn't matter where one thing happens, you can simply migrate it to another as needed. And finally, through our monitoring agents, we can also monitor your own models that are already deployed and in production, but simply bringing in the monitoring statistics to provide you with one location where you can monitor all of your models regardless of where they're deployed. So let me spend a couple minutes talking more in depth about how we monitor on your models. So this first screen here is what we call our deployment inventory. And this is where we can provide a single pane of glass where you can see every single model in production and immediately get an understanding of your production AI health. This can also be very helpful to flag models that do need your attention so that you can prioritize your time based on which models are most at risk. As part of this monitoring, the first dimension that we will provide monitoring for is service health. And this is what I like to refer to as the IT metrics, where we can monitor things such as the volume of data that's coming through your model, or response times, or even error rates, so that you can make sure, are my models functioning properly, and are they scoring at the volume that I expect them to? On the data science side, we provide accuracy monitoring, so that over a model's lifetime, you can continue to evaluate, are my predictions still accurate, and how do they compare to what I expected from training, so that you can quickly identify when a model's accuracy is deteriorating, and then be able to take action to improve it. Of course, with accuracy, we do need the actual results, and that can sometimes take a week, a month, maybe a year. There may be a long lag time between when you actually observe whether a prediction came true. And on that front, if you do have that long lag time, you might have a model in production for some time before you realize that it's not performing at the level you need it to. And that's why we also provide data drift. This is something that's available at the time of prediction, so that you can understand, is the data that I'm scoring on somehow changing from the data that I trained my model on? And this can be a great leading indicator for you to identify, is my model at risk of no longer being relevant to the current situation? Maybe your customer behavior is changing, or maybe there's a pandemic in effect, which can change the nature of the systems that you're trying to predict. Data drift can help identify that upfront at the time of prediction, so that you can be proactive about taking action and make sure that your AI systems are as performant as they can be. And finally, along with all of this monitoring, we do provide notifications as well. You can imagine, as you start to get to 5, 10, 100 models in production, the amount of time to monitor every one of them manually will be considerable. And so we have notifications set up where you can customize your own thresholds. At what point would you like to be notified of a problem or that something needs your attention? And then automatically receive alerts telling you this model needs your attention and because of these reasons. These are available through email, but we also have the ability to integrate with common messaging systems such as Slack as well. And so those are the first two tiers of MLOps, deployment and production monitoring. So let me dive into lifecycle management next. The core concept around lifecycle management is the ability to replace AI models with new ones. So as time goes on, as scenarios or environments change, your model might become stale. And so the ability to replace that model with a brand new one without service interruption becomes critical. Especially as it comes to comparing not just is my model working, but model performance, and maybe comparing champion challenger models to see if you have alternative models that might be better, not today, but maybe a week from now, they become better. And so that ability to seamlessly swap between them and to update your models becomes very important. And with that model replacement, we do provide full approval workflow to manage notifications and model replacement, so that you can make sure that models are replaced when they need to and with the appropriate people coming in to approve those changes. And so finally, let me talk a bit about model governance. So with DataRobot, we provide a variety of different tools to help you govern your models in production and make sure that you have a record of all of the changes that are made to your models, so that you can properly comply with audits, with regulations, and to have a historical record to make sure you understand exactly what's going on with your AI systems. And so the first one here is permanent model archiving. So one common issue we've seen in production systems is that even if they do have the lifecycle management down, where they can easily swap in a new model, it doesn't remove the need to keep track of that, to make sure that you have a record of prior models and of their predictions. And so this model archiving provides an instant access and the ability to explore previous models, so that if you do need to go back in time and understand what happened at a prior moment in history, all of these records are kept so that you can go back and validate that you know exactly what happened. And alongside of that, we also provide a complete audit trail. So not just keeping a record of prior model predictions, but also understanding the people and the reasons why changes are made to your models. So whether this is model replacements, where you can keep a log of who submitted the new model to replace the current one and who approved it, as well as any potential requests they may have had for updating the new model. All of those records are logged, in addition to things such as changing importance, flagging which models are critical to your business versus which models are simply nice to haves. And all reviewers and model changes will be able to keep involved with these logs and have a record for your college. And finally, we also provide the ability to import existing IT security policies for both users and groups, so that you can make sure only the appropriate people have access to the appropriate roles and capabilities. So as you might expect, you wouldn't want, after you've deployed a model, you wouldn't want just anyone to be able to come in and replace that model or delete the deployment. And so being able to set up these role-based access controls can help you manage risk and make sure that only the appropriate people are able to replace models, are able to approve model changes, and be able to see what's happening with your AI systems. Alongside of this, we do have the ability to integrate with directory systems like LDAP, if you do have predefined groups or roles that you'd like to implement. And so finally, to recap through the machine learning operations, so to bridge that production gap, we provide the ability to scale the volume and sophistication of your production AI through automation. You don't need to manually configure every little detail. We have automation set up to make sure that you can do these seamlessly and quickly without becoming too time-consuming. You can monitor, maintain, and improve the quality of any deployed model. So regardless of where they've been deployed, how the model has been built, or where they're located, we provide seamless access to monitor and maintain your AI systems all within one place. This also establishes collaboration between your data science teams and your IT operations. So no longer are they going to continue trying to learn how to translate what they know into new systems or to different programming languages. Your data scientists can operate in the languages they prefer, and your IT operations team can operate in the languages they prefer, while still having that single source of truth so that everyone is aware of the health and status of your AI systems. It also provides compliance and risk management for your machine learning environment so that you can implement controls and manage the risk of your AI systems and make sure that things are happening as the business requires them to. And finally, closes the production gap in your AI enterprise strategy, so that we can solve the issue of not being able to maintain and manage your AI systems. We provide a single place to allow everyone and all stakeholders to work together in utilizing AI. So with that, thank you for your time, and are there any questions?
So thanks, Jake. I think we'd be remiss if we didn't show the tool because DataRobot is just such a cool tool. So could you just go into it and then share just a little bit about the interface? And at the same time, if anybody has any questions, please share them with me.
Certainly. So let me pull up DataRobot. So the screen I have up here is what I referred to earlier as the deployment inventory. And this is that single pane of glass where you can see all of your models in production and their health across a variety of dimensions. And so just to briefly explain this, you can see at the top of my screen here, I have 14 active deployments. I've made roughly 3 million predictions in the last 7 days. And across the 3 dimensions that I mentioned, service health, data drift, and accuracy, most of my models are in good health. We can see that I've got 1 model at risk for data drift and 1 model that's failing. So I can very quickly hone in and say, I have 2 models that need my attention to see whether this is a problem and whether I need to take action. And from below that summary tab, we have each of my deployments, which are active currently. You can see I've got 1 model that's still waiting for approval to show the approval process and workload required. But I can very quickly identify this compute optimization deployment is the one that has been experiencing drift. And so this one can probably use my attention. Of course, this is a demo, and so I know that this is not on live data, but we can use this to quickly hone in on what I need and what kind of attention it needs. And for those governance personas out there, we can also switch the view of this pane of glass to be more governance oriented, to showcase which of these deployments are important or are more important than others, where they've been built, whether it's DataRobot, Java, or something else, as well as the owners and how long these models have been in production.
Jake, since I have a partner perspective on things, can you share a little bit about how you connect to the other partners in the Ironside ecosystem?
Certainly. So let me jump into one of these models. So Lending Club, for those, this is a loan default use case. So basically trying to predict if I have a new application, how likely is this loan to default? So this is a model that's already been deployed and is in production. But in terms of how we collaborate with partners, let me come to this predictions tab. And this is where once this model is built, you can start to leverage it to make new predictions on new data. And as part of this, we do integrate with a number of different partners to help make sure that these predictions are available in the systems that you are used to using. So you can see here, I've got a couple examples with Microsoft SQL Server, Tableau, and Snowflake. And these integrations provide a seamless way for you to provide new data to this deployment to allow DataRobot to make predictions with your model, and then send them back easily to your partner. So whether that's Microsoft SQL Server or Snowflake, which are 2 popular database tools, you can simply send the predictions right back into your database. Or for example, Tableau, which is a visualization tool, we can simply send it back into your Tableau environment so that you can then surface these predictions in the visualization tools and dashboards that you've already built.
Thank you. We don't have any other questions, so we have a couple minutes if there's anything else that you wanted to show.
Sure. Well, let me take one minute then to talk about 2 new things that we rolled out that we're really excited about. So beyond the machine learning operations functionality that I've talked about, we did just roll out something we're calling Humble AI. And with Humble AI, we want to be able to provide tools for data scientists, business analysts, and the various personas to be able to say, I know the weaknesses of my AI system. Here are the areas where I think that we should not be making predictions or that we want to be cautious about, so I can be humble about the capabilities of my AI systems. And the way that sorry about that. The way that we've implemented this is by giving you the ability to implement rules on top of your predictions. So that, for example, I can come in here and say, in this binary classification problem, my prediction is some value between 0 or 1. How likely is this loan to default? But I can come in here and say, if my model is extremely confident, if it provides a prediction lower than 0.0035 or above 9885, that's a model that is extremely confident in the result. So I can come here and say, I don't think that any of our applications will be that clear of their default probability. So I can come in here and override that model prediction to say, I want to classify this as a default and I do not want to fund this loan because my model is overly confident in that prediction. And same thing where if I know my customer base, I can also implement rules on their attributes. So if I know that their annual income, the annual income of my customers is for the most part between $10 a year and $1 million a year. That's what this model was trained on. So if I see someone come in with an annual income outside of those bounds, maybe I still want to serve the prediction, but I want to keep a record of this. And so I'll say no operation, but I want to be able to flag these uses and say, this is something that we need to pay extra attention to because it's outside of what we're used to seeing and what this model is trained on. And with this, I can come in and look at a summary tab to see how often these rules are being triggered over time. And so with this humility, we can start to place business rules on top of our AI systems to make sure that we are implementing these models in a way that makes sense for our business and that we're comfortable with.
Thank you, Jake. And thank you, audience. We're really glad that you joined us today to Take 30 with Jake, the data scientist from DataRobot, one of the Ironside partners. And we hope you have a great week. Take care. Bye-bye.